What's up? What's up? What's going on? I am back with another video. This is going to be your binomial probability and expected value quiz for Thursday. I hope it helps. I hope you like it. Let's get started. Number one, a pair of dice is rolled 20 times. What is the probability that the sum of 5 rolls is exactly 5 times? All right, so exactly tells us we're going to do a binomial PDF. All right, so first of all, dice, what's the probability of rolling a die? All right, well, the probability of rolling a pair of dice is going to be, all right, well, we know we're going to roll 20 times. We got 20 trials. All right, but we got to figure out our actual probability here. Alright, so to figure out our probability, we're rolling 5. Alright, so how many different ways can you roll 5 with a pair of die, right? You got 2 dice. Alright, so dice 1, dice 2. Alright, we got to roll a 5. So we can go 4-1, right? We can also go 1-4. We can go 2-3. We can also go 3-2. Alright, and we could do... So we came up with 4 ways to make 5, right? Those are only 4 ways sums to get 5. Now, we also got to remember that, all right, there's 2 dice. So I got 6 possible outcomes on dice 1, 6 possible outcomes on dice 2. So that gives me 36 possible combinations I can make with a pair of dice, right? So this, to roll a 5, is going to be 4 out of 36. Alright, 4 out of 36, which we can reduce if we divide both by 4, that's 1/9. So right here in our probability PDF, we're going to have a probability of 1/9. Alright, and then we know we're looking for a total of 6 times. We want to get 6. 5 is actually 6 times, so there we go right there. So I'm not going to punch this in our calculator. I'm going to let you do that, all right? But when you do that, you get 0.0140, okay? So probability PDF, okay? Right here it says at least 4 times. All right, at least 4 times. So when we think about this one, when it's at least, remember, we're going to always subtract from 1. All right? Always. Matter of fact, here, let's type this in. So right here, whenever I see the keyword at most, all right, for my binomial CDF, what I like to do is, I like to do binomial, 1 minus binomial CDF. Alright, and then we have our trials, our probability, and then 1 minus our rate right here. Alright, or our x value, 1 minus x. I think that's the note said x, so 1 minus x. Alright, I like to do it. I'm sorry, x minus 1. X minus 1. I knew what I was thinking about, but x minus 1. Alright, so see how this says 4 times? Alright, what we're going to do then for this actual example here is we're going to do 1 minus binomial CDF, and we're going to do 20 rolls. That's the number of trials. Again, what was that rate? 1/9. Alright, and then we're going to do since x is 4, we're going to do 3 right here. Alright. Again, I like to do x minus 1, and then it'll work out. So when you do this, you punch that in your calculator. Again, I'm not going to do the calculator work, but 1.754. There you go, right there, 0.1754. Okay. Now for at most, alright, when you see at most, this is a binomial CDF as well, but the number of binomial CDF, sorry, of trials is 20. We got a rate of 1/9, a probability of 1/9, and then our actual number of specific events right here is going to be 5. All right, so there we go right there. We'll punch that in. Oops, put that answer there. All right, you do those in your calculator, you should get 98.9816 or 98.16%. All right, now moving along, a bag contains 4 red marbles, 6 blue marbles, 5 green marbles, and marbles drawn then replaced. So this is good. This is important. We draw a marble, then we put it back. All right. So overall, let's look at it real quick. Overall, we got 4 marbles, red, 6 blue, that's 10, plus 5, that's 15 marbles all together. So 15 total. 15 total. So when we put something back, we take one out, it's 14. We put it back, it's 15 again. All right, this is done 50 times. What is the probability that a red marble is drawn exactly 15 times? All right, so first of all, exactly. That means it's going to be a binomial PDF, right? So let me type, because my handwriting is just atrocious. So we're going to go binomial PDF, because it says exactly, right? So the number of trials we have is 50. The exact time, what's the probability? Well, the probability is going to be, we got 4 red marbles, out of, and we're drawing 15 times, so we want 4 out of 15, right? And then, exactly 15 times. So our number of specific events is 15 events, right? Right there. So that's what we do. 50, 4 out of 15, and 15. Okay. And what does that give us? Let me punch it in real quick. Normally I would put one up here, but I'm trying to keep this as short as possible. So 0.75 now. All right. This one, again, says at least 15 times. So remember, at least. All right. When it's at least, we're going to do 1 minus binomial CDF of our trials, our probability, and then our specific event minus 1. Okay. So this one right here is going to be 1 minus binomial CDF. Let's see, we got 50, and then we got red is 4 out of 15, and then we have 15 minus 1 is 14, right? Answer. Punch that in. That answer is 0.2402. Alright. And then this one says at most. Alright, so at most is going to be a binomial CDF. We have 50 trials, 4 out of 15, and 20 trials, or 20 expected trials. Alright, 20 successes. And what does that give us? Let's see. Type it. 0.965 right there. We got my equal sign. Okay. Now let's keep it going. Right here it says if June has a major If June has a major test next week and she has studied so that she is confident on 80% of the material, what is the probability that she will pass the test? Remember, passing is 70%. All right, the test is a 20-question test. So I think what we're asking here is for 70 70%, right? It's a 20 question test. So we first need to figure out what 70% is. All right, because 70 is passing, right? So if she knows 80%, all right, we know that we have a certain amount right out of 20 is going to give us 70%. All right, but we're going to say 0.7, right? So if I multiply 70 by 0.2, what that gives me is, all right, so when we do that, we get x is 14. So basically, we need to get 14 questions right. All right, 14 questions right to pass, right? To pass the test, right? To get at least a 70. So what we're going to do here is we need at least 14 correct. 14 out of 20. At least 14. All right, out of 20 to pass, right? So remember, at least we're going to do the binomial CDF, but we're going to do 1 minus. All right. So we go 1 minus. Binomial CDF. And again, we got 20 questions. All right. We studied 80%, right? So 0.8, or 0.80, doesn't matter, 0.8 or 0.80. And then it says at least. So remember, if it's at least, all right, we'll do 1 less, right? Remember how we did it, 1 minus r? See, at least was 15, we did 14. So we're going to do 13 right here. All right, when it says at least. And what does that give us? It is going to give us 0.9133, so 91.33%. All right, let's keep it going. Number 8 says approximately 3% of the eggs in the store are cracked. If you buy 2 dozen, all right, eggs from the store, what is the probability that, all right, first of all, 2 dozen, all right, hopefully you remember, a dozen is 12, 2 dozen is 24 eggs total. Okay, 24 eggs total. So now it says, what's the probability that none of the eggs are cracked? That means exactly none of the eggs are cracked. So when it's exact, that's going to be a binomial PDF. All right, binomial PDF. And we have out of the 24 eggs with a 3%, so 0.03. That 0 are cracked. All right, that 0 are cracked. And that's going to give us a total of 0.4814, so 48.14%. Okay. Right here, at least one of your eggs are cracked. All right, at least, again, that's at least. So remember, at least, we gotta do 1 minus, all right, our binomial CDF. And again, we have out of 24 eggs with a 3% probability that at least 1 is cracked. So remember, we got to do x minus 1. So since it's 1, 1 minus 1 would be 0. All right. And that's going to give us 0.5186. So 51.86%. All right, and then this one says exactly 2 eggs. Exactly. All right, exactly 2 eggs are cracked. All right. So exactly again means binomial. Take a guess. You guessed it. PDF. Binomial PDF. All right. So 0.03, comma, exactly 2 eggs are cracked. Okay. And we punch that in our calculator. Again, you got to punch these in. I'm not going to punch them in. There you go. 12.7%. Okay. This is basically an unrolled cube. Ours rolled out. But here we go. Alright, so you roll a number cube, alright, or die. Alright, that has 6 sides. Alright, but this different numbers on not 1 through 6, right? The values on the sides are as follows. All right, what is the expected value of the cube? All right, so what is the expected value of this entire cube? So again, expected value, guys. All right. So since this has 6 sides, you got to remember 1/6. The probability is 1/6. So the probability of rolling a 7 right now. 7 is 1/6. All right. The probability of rolling an 8 is 1/6. The probability of rolling a 9 is 1/6. The probability of rolling a 10 is 1/6. The probability of rolling a 6 is 1/6. Oops, 1/6. Oh, that's terrible. Let me fix that. All right, and the probability of rolling a 11 is still 1/6, right? Because it's 1 out of 6. So you throw all that in your calculator right there. You let that work. Or all right, right here it says at an annual county fair, you can win tickets to trade for prizes. A particular game has five possible outcomes. What is the expected number of tickets you can win? All right, so this is very similar to the one up top. All right, and what you do is you're going to do to win 12 tickets, you got a 0.34 chance of winning. All right, and then to win 35 tickets, you got 0.25 chance of winning. All right, 25% chance. To win 41 tickets, you have a 19% chance, 0.19. All right, to win 64 tickets, you got probably 14%. And to win 88 tickets, you have a 0.08 or 8% chance to win. All right, when you do that, 36.61. All right, that's expected value. That's expected number of tickets. All right, if the largest prize costs 20 tickets, all right, if the largest prize costs 20 tickets, how many of the large prize could you expect? Could you expect to trade for? All right, so we got 20 tickets, right? And that's very simple, man, right here. If it's 20 tickets for the large prize, and I subtract that from my expected value, right? Then I'm expected to leave here or leave that day with one large prize. All right, I'm gonna leave with one large prize, and I'm gonna have 16.61 remaining tickets. Told you my handwriting is bad. If you're not my student, you probably don't know that, but yeah, that's bad right there. All right. So one large prize for the day. Yeah, let's keep going. 14. All right, well, 14. All right, so right here, Archer Rose offered 2 jobs. A company A, base pay is $42,000, and there's a 60% chance of getting a $4,000 bonus. A company B, the base pay is $38,000, and there's a 30% chance of getting a $25,000 bonus. All right, which job is Archer Rose want? Or which job should Archer Rose take? All right, so for job A, they're going to pay him $42,000. All right, plus there is a 60% chance he'll get $4,000 additional, right? There's also a 40% chance he will not get the bonus. All right, so hey, I want you to understand this, okay? There's a 60% chance of getting this bonus, but out of 100%, if there's a 60% chance of getting it, there's a 40% chance you won't, okay? So we got to take that into account, right? So he stands a chance to make $44,400 right here, all right? Now for job B, all right, or the expected value is $44,400. Job B, all right, base salary $38K. I put K, I mean to put K. Plus the 30% chance that he'll get a $25,000 bonus. Alright. Plus the 70% chance, man, that's high. 70% chance that he gets no bonus. Alright, no bonus. Remember 30 and 70 would be 100%. What's that going to be right there? 45. 5. Alright, 45,500. Alright, so right there, what that tells us is which one should he take and why. Alright, take B. Alright, take B. Why B? Because the expected value is higher. Alright, expected value, alright, or pay in this case, is larger. Alright, expected value is larger. Alright, 15. A roulette wheel has 38 slots numbered 0, 00, and 1 through 36, right? The slots 0 and 00 are colored green. 18 of the other slots are red, 18 are black. The dealer spins the wheel at the same time, rolls a small ball along the wheel, alright, to the opposite direction. The wheel is carefully balanced so that the ball is equally likely to land in any spot when the wheel slows. What's the probability of landing on the red slot? Alright, so first of all, let's think about it. How many red slots are there? Well, they told us there's 18 red slots. Out of how many slots total? 38. Alright, there's 38 slots total. Those two green, plus all those other ones, 38 total, right? And they also said 38 slots, right? So we have 38 slots numbered. 18 out of 38 is going to give us, this is the probability of red, right? Probability of red. Alright, we can reduce that, right? They both divide by 2, so let's say 9 out of 19. 9 out of 19 probability of getting red. Now, if you place a $1 bet on red, alright, a $1 bet on red. So I'm going to bet $1 on red, 9 out of 19. Alright. You will win $2. Alright, you will win $2. So hold on. Now let me explain why I put 1 right here. Alright, you see how you placed $1 to win $2? Well, this is not actually worth $2 if you land on red. Right? To even get in the game, right, I had to pay $1, right? So the prize of $2 is really only worth $1 to me, because if I pay $1 to get in, alright, I give you $1, right? And then I win $2. That means I won my original $1 back plus $1 additional $1. Alright? So if you land on red, you win $1. Now, let's talk about if you don't land on red. What happens if you don't land on red? Well, if you don't land on red, oh Lord. If you don't land on red, you're actually going to lose your money. Alright? And you're going to lose your $1. Right? I lose my $1 if I land on anything else. So that would be 10 out of 19. And why did I say 10? Because 9 and 10. So if I land on red, I win $1. If I don't land on red, I lose that $1 that I initially invested. Okay? So when we do this, okay, that's going to give us a negative, actually, negative 0.05. It's going to be my expected value right there. Negative 0.05. Alright, and I think the thing to remember here is, guys, alright, you must subtract expenses. Subtract expenses. Expenses from winnings. Alright, so subtract your expenses from your winning, right? Before you multiply. All right, 16, same type of problem, okay? A person created a game in which a player pays $2 to play. So listen, you paying $2 to get in. So whatever the prize is worth, you got to subtract your $2. All right? So look, then they roll a standard 6-sided die, all right, 1 through 6. If it lands on 5 or 6, they get $5, all right? I.e., they get their original $2 back plus $3. See, you got to subtract. All right, so that's going to be 3 if you land on 2 out of 6. Or you can say 1/3, right? And then if they roll anything else, they will just lose the $2 they paid. So I'm gonna actually make that a minus my $2 if I land on anything else, which would be 4 out of 6, right? Which would be 4 out of 6. That gives me a negative 0.33 for my expected value. So I just want you to remember that they gave you gotta subtract, guys. You gotta subtract your winnings from your alright. I thought there was one more page of these. Oh, is that it? No, wait a minute. Alright, here we go. An insurance company agency charges male 16 to 18 year olds a base price of $1,100 for insurance a given year. Their accuracies have determined that there's an 8.5% a claim will be made against such a policy at an average of $4,900. All right, what does the insurance company expect to make on average off each policy holder? Okay, so this is the same thing. All right, now check this out before we start. Remember, everything must equal 100%. So if there's an 8.5% chance that a claim will be made against this policy, right? If I do 100% minus 8.5%, that leaves me with a 91.5% chance, all right, that there's no claim, right? No claim. So let's look at this. Base price is $1,100. You're going to pay this, right? $1,100. Well, there is a 91% chance, a 91.5% chance, all right, that the insurance company will earn just the base price. That's all they'll get, right? Oh, excuse me. That's all that this is all the this is all the insurance company will get, because it's 91.5% chance you won't get an accident. You just have to pay this for insurance, right? Now, there is this other 49. There's this other percentage that says that there will be a claim of $4,900 made against you. Actually, you know what we need to do? It's not $4,900. We gotta subtract that out, because the base is what you paid. So if you have $4,900, it's just like the last problem, right? $4,900 $3,800. All right. So there's an 8.5% chance that the insurance company will lose $3,800 on the 16 to 18-year-old drivers, because somebody will make that claim, right? So what we do is we multiply that, and that is going to give us $683.05. This is the expected value of an average. On average, the insurance company stands to make off a 16 to 18-year-old policyholder. All right, we're almost there. 18. An amusement park orders 500 small stuffed toys from 4 companies weekly. All right, if the company, if the price for the order per week are as follows, what is the amusement park expected to allocate in their yearly budget for small stuffed animals? All right, so 15%. Well, let's see. They got 52.5. 52.5. That'll be the price for 15% of the time, so 0.15. All right, and then there is a $105 bill for 45% of the time, and then there is a $75 bill for 20% of the time. And then there's a 69.75 for 20%. So that's just calculator work, right? That gives us $84.08 per week. Now, notice the question here say yearly, right? We compare the weekly prices, which this is per week, that's the expected value per week, to the yearly. All right, so if we compare it to yearly, then we've got to understand that if this is the weekly, there's 52 weeks in a year. So if I multiply 52 weeks times 8408, that gives me $4,372.16 per year. All right, 19. 2 more problems, guys. On a dartboard, there are points for hitting the different sets of rings around the bullseye. To simplify the game, we're going to use only 4 rings. The outermost ring on the board, thin, all right, then middle ring, wide, and then the bullseye. Okay, what is the expected value for each dart to be thrown? All right, so for 30 points, you got 12% chance. 0.12 times 30. All right, for the middle rings, you got 50% chance. All right, and then for the second middle ring, 33% chance you'll get 20 points. And then for the bullseye, you have 5% chance of getting 50 points. All right, so make sure the decimals are right. And we do that, 17.7. All right, is this better? And then grand finale. What you are playing, if you are playing, I don't know what's wrong with me. If you are playing a simple scratcher game for the lottery, you pay $1 for each card. So we should subtract this out. All right, subtract that out because I'm paying to play. All right, you can write the amount shown on the scratcher. There's a 1% chance of winning $100. So there's a 1% chance, 0.01, of really winning $99 because I got to subtract 1 from 100. Right? All right, and then there is 15% chance of winning $20. So 15% chance of really winning $19. All right, then a 25% chance of winning $10. So really $9. Okay. I paid $1 to play. And then there's a 25% chance of winning $4, not 5, right? 4. All right, and then the rest of you that played you'll simply lose a buck, right? You'll just lose a buck just because you decided you wanted to play the game. All right. Anyway, you can punch all that straight in. Okay, all that straight in. You're gonna whop 6 points. Alright guys, that is it. That is my time. I went well over 30 minutes. My apologies, but I hope this helps you prepare. I'm sure you know by now this is open note. Wink, wink. Good luck. Catch you up later.